So the first question asks, what's the surface area of the paper cylinder without the bases? Now, think about what we did. We took a piece of paper and we rolled it up. That paper, when we started, was just a rectangle. And that rectangle was 8.5 by 11. So the area without the bases is just the 8.5 by 11 sheet of paper, which is approximately 93.5 square inches. Now the question then comes into, well, how do we deal with the fact that if we want to add circles, we want to enclose it, we want to put a circle on each end. So if we do that, we know we need to make two circles, okay? So we know we need two circles. And in a circle, we know that the area is pi times the radius squared. So we need to figure out the radius of this circle. Well, we can't just say what the radius is, but what we do know is think about how this is rolled up. If I think about how that's rolled, that roll is coming from this edge here. Now think about what that's making. If I'm taking the edge and outlining a circle, that means the edge is making the circumference. Now I can figure out the radius from the circumference because I know that the circumference is equal to 2 times pi times the radius. So if I know the circumference is made up of this side, which we know is 8.5 inches, I can say that 8.5 will equal 2 pi r. So if I divide both sides by 2 pi, I'll get that the radius is approximately 1 35 inches. So when I want to find the diameter, as it asks for the diameter and the area, I know then that the diameter would equal 2 times the 1 35 because it's 2 radii make up a diameter, which is about 2 7/10 inches. And then my area for each of those circles would be pi times the 1 35 squared. And that will be approximately 5 73 square inches. So each circle is about 5 73 square inches and will have a diameter of approximately 2 7/10 inches. All right, now the last problem here asked about finding the surface area in general. Where does that formula come from? So we have two parts to it that are being added together. We got the 2 pi r squared and the 2 pi r h. So some parts should look a little bit familiar there. The pi r squared, that should make somewhat sense because pi r squared is the area of a circle. So the 2 pi r squared comes from the two circles. If we say that their radius is r. And we know that those circles have to be congruent to one another. So then the problem comes into, well, where does the 2 pi r h come from? Well, the h, we know we get from the side that connects the two circles in a cylinder. So then the question is, well, why is this labeled then? We think about what's going on, that has to be the 2 pi r h. I'm sorry, that has to be the 2 pi r, because the h is on the other side. So 2 pi r times h, because it's length times width. So 2 pi r. Well, 2 pi r, we should remember, is the circumference. That's one of the two ways. We can either say it's the diameter times pi, or it's 2 times the radius times pi. Well, why would it be the circumference? Well, think about what's happening here. If we think about going around the circle, and what we do when we create the net is we're going to unpeel the circle, and it creates the straight line here. and then I unpeel it this way, and it's going to create this straight line right here. So I'm taking the circle and peeling it and laying it in a flat straight line, and that gives me the circumference, which is the length of my rectangle. And then the h, the height, is the side that connects my two bases, which are circles. So 2 pi r squared comes from the area of the two circles, and then the 2 pi r h is because it's the circumference of a circle times the distance between the two bases.